Hello students and IOPians, you are most welcome in this series of very important question for the board exam. And now I am starting with chapter number 1, Rotational Dynamics. Question number 1, derive an expression for the kinetic energy of a body rotating with uniform angular speed. Question number 2, define moment of inertia of rotating body and state its SI unit and dimensions. Question number 3, state and prove the principle of parallel axis theorem for rotational motion. Question number 4, explain the principle of conservation of angular momentum with the help of example and derive its expression. Question number 5, define radius of gyration and give its physical significance. Question number 6, obtain an expression for torque acting on a body, rotating body with constant angular acceleration. Next theory question, derive expression for the lower speed limit on a curved banked road. Then next theory question, derive expression for frequency of a conical pendulum. Next theory question, show that the difference in tension at the lowest and highest point in a vertical circular motion particle tied to the string. So these are the important theory questions. Now we'll start with the numericals. Question number 1, a motorcyclist is to undertake horizontal circle inside the cylindrical wall of a well of inner radius 4 meter. Coefficient of static friction between the tires and the wall is 0.4. Calculate the minimum speed and frequency necessary to perform this stunt if the value of gravitational acceleration is 10 meter per second square. Question number 2, a pendulum consisting of massless string of length 20 centimeter and a tiny bob of mass 100 gram is set up as a conical pendulum. Its bob now performs 75 rpm. Calculate kinetic energy and increase in gravitational potential energy of the bob if pi square is 10. Numerical number 3, a flywheel used to prepare earthenware pots is set into rotation at 100 rpm. It is in the form of a disc of mass 10 kg and radius 0.4 meter. A lump of clay of mass 1.6 kg falls on it and adheres to it at a certain distance x from the center. Now calculate x if the wheel now rotates at 80 rpm. At the same time, you should know the application of principle of perpendicular axis theorem and parallel axis theorem for finding the derivation of different axes in case of ring, in case of disc and spheres. So this much is there for this chapter. Thank you, take care and bye-bye.